快，
就像昨天不是给，然后我是给。
Are you ready? Okay, ready.
No.
Worries. Can I ask about
I think I can finish this a little earlier. Then later you can ask about the assignment. Yeah, so start now. Okay, so today we will be doing supervised machine learning. The idea is very simple. We want to make machine to be able to learn from the learning material. Of course, machine cannot do anything until you teach machine how to do the learning. That's the reason why we need to get ready learning material and also the learning style. How you want the machine to learn from the learning material. So the learning style refers to algorithm. Okay. So when you want to do machine learning, there are a few ways of doing it. But for this subject, we will only be covering classification and clustering. So today we will be doing supervised machine learning. For supervised machine learning, you can do either classification or regression. So we will cover this. The two, they are very similar, just that for classification, you want the machine to predict a category or a class. For example, gender, male, female. So you want the model to predict whether someone is male or female, right? Classification. So the number of categories is countable, countable. Maybe 2 categories, maybe 10 categories, maybe 1,000 categories. Okay? It doesn't mean that when you have 1,000 categories, then there is regression. For regression, you want the model to predict something like a real number. For example, maybe your salary, your height, your weight. So we can have something like 101, 101.5, 101.51. So there are too many possibilities. So we cannot identify all the classes. That's why we do regression. Okay? So even though it is stated here, when you have more than 50 samples, you can do training. But I don't think this is good enough. You can try to find data set with only 50 samples and you do it. And you will notice that the model can be trained, but it will perform very badly. Okay? Okay, so the idea is very simple again. We want to train a model. The model is machine's understanding of something. For example, you want machine to understand whether given an image, it is a cat or non-cat. So you must get ready the learning materials. Image with cat face, then you put the label there, cat. Image with cat face, then cat. Image with non-cat face, then non-cat. So if you have gotten the learning material, you identify one learning style, which is the algorithm, the learning will begin. At the end, one model is trained. Then you can actually pass new images to the model. It will tell you whether it is cat or non-cat. So this is how it looks like, classification and regression. For classification, the model will only be doing this. Let's say given one input, it will put the input either here or here into one of the categories. In this case, we have 2 categories, right? You can have 2, you can have 3, you can have 5, you can have 10, you can have 20, or 100 or more. But for regression, it will try to predict based on this line. Okay? Of course, this is a straight line. In actual situation, right, we can have straight line or curved line. So this line represents the general pattern for the whole samples that it has learned. Okay? So this is the line. Then it will try to do prediction based on the line. Okay. When you want to do supervised machine learning, you can choose to do whether classification or regression, depending on how you ask the question or how you want to solve the problem. Let's say you want to do weather forecasting and you want to know what is the temperature value. Then you cannot do classification because you want to know the value. The value can be 84.01, 84.0111. So there are too many possibilities. Regression. But if you change the way you ask the question, will it be cold or hot tomorrow? So it is either cold or hot, right? Then classification. So this is one class, another class, or one category, another category. So it depends on how you ask the question. Okay, so this is a general flow when we want to do supervised machine learning. First thing first, get ready, label data set. So this is the learning material. Everything begins from this part, learning material. But machine cannot understand images, machine cannot understand text, machine cannot understand the audio, right? So you need to find a way to convert all these raw materials into vectors. Vectors are actually numbers. So machine can understand numbers now, because fundamentally machine understands 0, 1, 1, 0, right? They are all numbers. So as long as you can convert something into numbers, machine can digest it. And if you pick one algorithm, which is the correct one, the learning will happen and it can really do the learning and one model is generated. If you choose the maybe wrong algorithm, right, the learning will still happen, but maybe the model train is not so good. Once the model is trained, if you have new text or new document or new images, you want to use this to do prediction, then make sure that you also convert all these things into vectors in the same way, like how you did just now. Must be the same way, same way. Then you convert it and the model can tell you what is it. So what the model can do is that it will only predict an output. So this is not a god, this is just a model. So it can make mistake one. Okay, fruit classifier, for example, if you want to train a model that can actually tell you whether something is an apple, orange, or grape or not, make sure that you can find the data set. Of course, this example is a text-based. You can also find those in images. So if let's say you are given this, you want to train a fruit classifier, a model that can predict whether a fruit is apple, orange, or grape, you need to find this information in the data set. So if let's say we cannot find something like apple, orange, or grape, right, we cannot do this thing. Fortunately, we have one column here, fruit type, apple, orange, or grape. Oh, okay. So this will be the label or the output. And the rest of the columns, right, you can use them as the inputs or you can use some of them. Either all or some. It depends. For example, if let's say you assume the size of orange is big, this is medium, this is small, then size is actually important. Because by referring to the size big, you can tell this is maybe orange. Okay. If let's say color, their colors are not the same. Red, orange, purple, let's say. Then color is important. But if you assume that all of the three types of fruits, they can be imported from all countries. So when we tell people China, you don't know whether it's apple, orange, or grapes, because it can be anything. If let's say apple can only be imported from China, then okay, maybe country is important. So if let's say you notice that one information here is not useful, right? Drop it. Because it will not help machine to do the learning in a better way. This is not contributing anything. We want machine to learn from here how this is connected to the output. So when given these two information, right, machine can tell you whether it is apple, orange, or something else. So later we will be doing this binary classification. It means that there are only two categories. We will be using traditional machine learning, logistic regression, and naive-based. Even though this is a traditional one, they sometimes can perform better than the deep learning one. Okay? So if let's say your target is that you want to do something at a lower cost, then maybe the traditional one would be your option. Okay, so we'll be doing this. We want to train a model that can detect whether an email content is spam or non-spam. Okay, so we will go through a few examples before we look at the code because we will be using some of this in the code. Okay, this is the normal way for us to define a function. We use the def keyword, the function name, followed by parentheses, and then the parameter, and then the expression. Okay, so this is the normal way. But you will find people prefer to define function not in this way, but in this way. This is called lambda function. Okay, when we want to define lambda function, we have to make sure that the function is really very small. So it is so small that the expression can be put into only one line. If let's say the function is so complex that you have many lines here to do many different calculations, you cannot put them into one line, then you forget about it. So lambda function is meant for small anonymous function. So you see, when you define lambda function, you don't have to think about a name one. Okay? Lambda keyword, the argument, in this case, there's only one, and the expression. So you give the function one value, it will tell you whether this is even or odd. One line only. But we want to use the function, so we have to assign this to any variable. Then you can use this function through this variable. So in this case, we can use this lambda function through the use of this variable. You can check result actually is a type of function. Okay. So we have another example here where we have two argument values passed to the function. So later we have lambda functions defined to do quick processing. Of course, if you think that code is long, doesn't matter, right? Then you can actually write the function in normal way. But if you want to write short code, right, do this lambda function. The code will become very short. Okay, next, invoking functions with and without parentheses. So when we do Java programming or C or C++, we know that when we have defined a function, when we want to call the function, we write the name first, right, followed by parentheses. This is normal one. So everybody knows about this. in Python, you can actually do the function invoking in a different way. You can call a function by writing the name followed by parentheses or without parentheses. It can still work. It can still work. So we use one example here to understand what's the difference between the two. When you write the function name followed by parentheses, right, the function when it is called, immediately it is called. Immediately. But when you write a function name like this, without parentheses, it is possible that it will be called when it is needed. For example, this one, when we use substitute to go through the text to find any matches in the text based on this pattern, only if one match is found, it will pass the match over here to do lower case conversion. If no, then this will be invoked. Okay? So this is possible. So when you do Python programming, if you see something like this, don't be surprised. Okay, the last one, map. If let's say we have defined one function, we want to pass a number of items or values to this function to do multiplication. Let's say we have a list of values. Normally we will use for loop, right? Look through the list and then we do this multiplication. But you can squeeze everything in one line like this. Map a function to a collection. So this mapping will take the value one by one out and do multiplication, and it will send the output over here. Another one, send it over here. Another one, send it over here. But the output is not like a list, no? So when you print output, you see, it is a map object. The values are stored somewhere, but you cannot access it directly. If you want to access it as a list, right, you have to manually convert it as a list. Okay, let's see if we can do this, make it a set. Also possible. Okay, so if you want to access a value, you have to convert it to a collection. Otherwise, you cannot access it. So now it becomes a set. So okay, okay, so these are just the basic. Next, okay, reading data set. So we have one data set here, the spam.txt. It is possible that the text or the data set is put in this format, text file, or CSV file, or JSON file, or any file. So you need to find the relevant function to read the content. So from here you can see this data set is so simple that it only has two columns, 1 and 2. And it makes sense, right? If you really want to know what is spam, then you must be given many examples, right? 10 means spam, non-spam. If you want to know what is non-spam, you must be given many examples. So this is a learning material because we want to make machine understand what is ham, what is spam. You must give the machine many examples. Of course, you can give a few, but the model that you train, right, will be very lousy. Okay? So we do this, we read it first. There are times, once this is done, right, some mistakes will be made. So please check our code. The first record is mistakenly treated as a label for every column. Then you need to do it again. Okay? So now it becomes 0 and 1. This becomes the first record. And we can use the code that we learned last week to relabel the column. So now we make this label, we make this text. It is possible that the data set that you're going to use for your assignment, it has many columns. And there are times the output or the label is put in the middle. You can use this reindex function to swap the column. You can actually put it here on the left hand side or the right hand side. But if you put it in the middle, also okay, but it can be confusing. So I don't have the code here. I think only 1 or 2 lines. You can try to explore the code to see how this works. You can try to swap the two. Make text come first and then followed by a label. Okay, EDA. For data science students, they will take one subject called data science. And then when they take this subject, right, they will learn how to do visualization. So they will be given, for example, data set, then they try to understand the data set, then they will do many different diagrams, generate diagrams from the data, try to understand the data set. So one possible way we can do it is that we can use the predefined functions. For example, we want to know very basic information about the data set, but we have already put it into data frame, right? So we can apply this onto the data frame, like this, data frame.info. So this is so basic that you can only tell how many columns are there, how many records are there. Okay? So the D type here, if you want, you can also access D types. Then you can access the value object. You can use describe to access more information. Okay? Because this data set, you can see that we can only see text, no numbers, right? No values. So we cannot have information like what is the maximum value, what is the minimum value, what is the median. We cannot have this thing. But if you change this to a different data set with a few columns with numbers, then you will have more values here, maximum, minimum, and so on and so on. Okay? So here we can see that we have 5,500 plus rows. Not bad, but this is still considered small. Okay? Small. Even if you have 10K, 20K, that is still considered as small. Maybe 50K, 60K is considered medium. Over 100, 200 can be considered as maybe either medium or big, huge. So unit for label, we have ham or spam, 2 only. So it means that we have 2 categories only. But for text, we expect to see 55721, 5170 only. It means that some records repeat. For example, sorry, I will call later, this repeats, we have 30 of them in total. Okay? So if you think that there are too many of them repeating, right, you can drop the duplicated data. Okay? But for this one, this is actually not bad. This is not good. Because ham, we have too many hams. If you have many spam, then good. If you want to train a model to predict ham, then this is good. If you want to predict spam, this is bad. Because in total, we have 5.5K, right? But more than half, they are all ham. So it means that you want the model to predict and identify spam, but you only provide little information about spam. So it will not be able to learn enough. So later we will do experiment to see whether it can predict ham better or spam better. Okay? So by right, we should be able to see answer like maybe ham is better than spam. Okay? Now is now value. So we can use this. If let's say we have something like this, for example, I remove this. Okay? Or let's say remove this. If you have something like this, right, then you will be able to see now value in the data frame. So if let's say something like this happen, right, normally we will put one value here, insert one general value here, another one here. Or we will just remove the record. So it is important for you to check to see whether there's any null record or not. So we check, right, too many we cannot see, right? Then we use sum to tell us how many of them is null. 0, 0, none. So not bad. Okay? If you want to know how many unique values in each column, then you can do this. And what are the unique values, you can do this. So this is just to do something to help you understand the data set. Then next, is there any duplication? We cannot see it, right? Use sum. Yes, 402. Okay. If you want to remove the 400, it is still fine because we have 5.5K. But 5.5K is considered small, not a big data set. Okay, hey, make it a habit to visualize some records. Let's say you want to see the first 20. If you look at the first 20, right, you can see something is not right here. It is too noisy. So we have punctuation, we have number, we have words written in uppercase letter, and then we have something like this. C. C is the same as SEE, right? U is the same as YOU, right? We can understand this, but machine cannot understand this. So you may want to consider to do text normalization. So for example, convert all the C to SEE, convert all the U to YOU. And whether the machine can understand this or not, that's a different case. Maybe we have HOR, we have HORR, or we have HO. We don't know. So this is considered as noise. So for this exercise, we will do a simple pre-processing only. We will only be removing numbers, punctuation, and also lowercase conversion. So if you think that there's still noise, you can do it more.
Change U to maybe Y or U 它会不会等下别的字有 U 的可以换掉
No, you have to write the code properly. When you do this replacement, you replace it with something else, right? The pattern that you write must be the right one. If you write the wrong pattern, then all the U will be changed to YOU. Okay, so this is very important because there are times when you print the first 20, you see many ham. If you want to see spam, then how? Then you can do this. So this will allow you to see only, for example, all ham or all spam. So we can do this after we have gotten the model trained and it generates result. And you notice that the model is not doing very well. You want to know why? Why? So you look at the wrong prediction. Let's say I print all the wrong prediction. I see what is not right here and there. So it is important for us to know how to enhance the quality of the model, but not just train then use it. Okay? So we will be doing very simple data pre-processing. So we define lambda function. We define another lambda function. So this is used to remove numbers. This is used to remove punctuation and do lowercase conversion in one line. Yeah, so we assign this to no number, we assign this to no punctuation and upper. So once you have defined lambda function, right, you can do this. Okay, so what is this? So you can print this, copy this one, and then print this. So we have one whole column labeled with text printed. So this simply means that you map the entire text column with this function. So we use this function to remove all the numbers from this column. Then we map the output from here with another function, and we want to remove all the punctuation and all the uppercase letters from the column. So either you do it like this or like this, both are the same. Okay, both are the same. But the sequence is also important. If you have many steps of pre-processing steps, right? If you do it in different sequences, it is possible that the model performance will be affected. For example, okay, if you look at record 13, we have something like this. Okay. So if you look at the record before we do pre-processing, 13, where's 13? Because we remove punctuation, right? We accidentally converted this into an invalid word. So the sequence is very important. So next time when you do this, make sure that you plan ahead how you want to do it. Let me do this again. Okay, plan ahead. So now, okay, I just write something here. If I'm not mistaken, it should be named like this: contraction expansion. So if you want, you can do something like this as one of the pre-processing steps. So this is used to do this conversion. So rather than just doing punctuation removal at the beginning, if you can do contraction expansion first, right? Something like this to be converted to something like this. You don't have to define the function by yourself. Just explore to see whether you can find any function that can do this in MLRTK. Then you can just call this to do contraction expansion right before punctuation removal. Otherwise, if you remove punctuation first, this cannot work now. It doesn't know what is this. Okay. So next, splitting data into input output. So we know machine learning is different from traditional programming. Before you start to do this, you need to first identify what is the input output, and this is the learning material. Then identify what algorithm machine will do the learning, and the model is generated. This model is the program. It is the program. So first thing first, we print all this. So simple only 2 columns. So you can easily tell what is the input, what is the output, right? In this case, text is the input, label is output. We want to show machine one text, and one machine to tell us whether this is spam or spam. So we show this one first, then only this one. Input comes first, then only output one, right? Then we split the data frame into 2 series. Every column in the data frame is a series. For example, this is a data frame, it has 2 columns, right? When you take this out, this thing alone is called a series. Okay? So now we make this into 2 series. This will be the input, and this will be the output. Okay? So this input, we use capital S. Of course, we can do this, but normally we will use this. The reason is that for this example, we only have 1 column to be used as input, but the data set that you find, it may have many columns that can be used as inputs. So big S means input or inputs, but we only have 1 output. We have many inputs or 1 input, but we definitely can only have 1 output. Okay. So next, we will come back to this again later. Okay. So we want to split the entire data set into training data and testing data. Normally we will get testing data from the same data set. We don't want to use something else as testing data, because if you have 2 different data sets, right, maybe there are things that not the same in the 2 data sets, but you're not aware of it. It will result in the model not being able to perform very well in terms of prediction. So we want to randomly select some of these to become testing data. So you don't have to do this manually. We either split into 70, 30, or 80, 20. There are also people who do this 60, 40. But we want the model to learn as much as possible. Then only we test it. There's no point for you to use 30% training data. Then you test it with 70. You can do this, but the model cannot perform very well because it learns very little and you want it to do prediction very well. Okay? So normally we will allocate more data to be used as training data, lesser to be used as testing data. But if let's say you use 99 here and 1, right, then this is also not good. Because 1% is too little. You cannot test the model very well. Okay? For traditional machine learning, we need only training and testing. But for the more advanced deep learning, you may need 1 additional set. So either you do it like this, you split the data into training, testing, using this function, train, test, split. Then you further split training into training and validation. Or you can do it in a different way. Okay? But make sure that when you have chosen one algorithm to train the model, your teammates have chosen others, right? All of you must use the same testing set all of you must use the same testing set. So if let's say all of you are tested using different final exam paper, even if you can score the same or score different, right, you cannot tell whether you are equally good or you have the same understanding or not. Because some papers can be easy, some papers can be challenging to answer, right? So testing set must be the same. We use train test split. So we pass x and y to this function. What is x? What is y? If you remember, earlier we do this, right? We split the data into x and y. X is text, y is label. Okay? X, y. Fair enough. So we have the original data set. We first have to identify what is x, what is y. Then you pass the x and y to this function. It will do the splitting based on the ratio here. So we want 30% test data and 70% training data. So you can think of this as the tutorial question, tutorial answer. We use this to train you. Okay? Then once you have well trained, right, we test you using final exam question. Then you will produce answers, right? Then we check your answers and the actual answers to see whether you are doing very well. So the machine actually will be tested in the same way. We get this thing ready, we have the training data and the labels. This is the question answer, we train the model. Once the model is well trained, right, we test it using the test data. And this test data should not have any trained data to be part of it. Otherwise, this is cheating, because the model has seen the extract already. So this one must be totally different from this, but they should be coming from the same data set. So you can just use this, it will do the splitting for you. And one important thing is that remember to include this random state. The value can be 2 or 0 or 1 or any number. But when you put a number here, 42, if you want to repeat doing the same experiment, replicate this thing, you just put 42 here, right? It will do the same split for you. Everything that you can find from X test, X ray, right, will be the same in this second round also. So if you do not do this, right, next time when you do it again, you cannot get the same split anymore. Maybe the percentage is the same, but the records are not the same. So this one is very important if you want to repeat doing the experiment again. So done. No need to do it manually. So you can check the X-train, X-test. We have split it already, right? But they are all in words. Machine cannot understand words, right? So we use what we learned last week. We want to convert all the text into numbers or vectors. So we use count vectorizer. Of course, we have other ways of doing this. So we have a count vectorizer, we have PF, IDF, we have ngrams, and we have others. And you can also use the most advanced word embedding to do this. Okay? So we try to convert it into vectors, and we do this step. So we create the count vectorizer object. Then we try to convert the training data. X is input, right? Y is answer now. Output. So X is the training data. So we pass this over here to generate a vector, one for each data. Okay. So when you do this, you must use fit transform. There are two processes here. Fitting means it will create a set of vocabularies from the training data. Then transform means it will convert all the text into vectors. So when you do this onto training data, you must use fit transform. And you must also do this onto testing data. But when you do it onto testing data, you must use transform only. Transform only. Because if let's say there are words in the testing data that cannot be found in the training data, right? It makes sense that you cannot understand it. So this transformation that we convert all the text into vectors is done based on the set of vocabulary created from here. So it is fair that if it doesn't learn anything new, but you can find it in here, right? It doesn't know what is that. Is that okay? So fit transform, we use it onto the training data. Transform only, we use it onto the testing data. Okay, once this is done, we have created the vectors. So we have done so many things. Actually, we are still at this step only. We are still at here only. Okay, so this one is very quick one or two lines only. So next, we will do this. We select one algorithm, and then we create one object. Then we fit this object with the use of the training data, question and answer. So the learning will begin and end so fast. Okay? Then you can test the model that you train using the test data, which is the question. So it will generate all the answers. Then later you can compare the answers generated by the model with the actual answers. Of course, this is a very simple one. We didn't do fine tuning, we didn't do anything else here. We just use it in the most default way. Okay. So if you want to enhance this, right, you can do additional steps. Okay. Once the answer is generated, then we can try to do something like this. Evaluation. This is very important. We cannot just train and use it. It is possible that the model cannot do any prediction correctly or not. So we need to check it out. Okay, we have one example here. I think this will be covered in the future 2 or 3 weeks. So we will quickly go through this. Just assume that in the test data, we have 165 samples or records. Okay? And if let's say the 165 records, 105 of them, they are labeled with yes. Another 60, they are labeled with no. Okay? Again, this is the testing data. We assume that this is testing data. And 105, they are labeled with yes. The rest of 60, they are labeled with no. We want the model that we train to predict how many of these, which one is no or yes. So let's say we use it to do prediction. The model predicted only 55 no. Only 110 yes. So you measure, not the same, right? 105 and 110. 55 and 60, not the same. So we check. The actual no, machine only predicted 50 of them correctly. The other 10, machine mistakenly predicted no as yes. The actual yes, machine predicted 100 of them correctly as yes. But machine overlooked 5 yes to become no. So from here we will know, actually still consider not bad. 150 over 165 is correct. The other 15 is wrong. Okay. Then we can actually do plotting like this. You can generate the diagram. Then later on you can calculate the accuracy, precision, advanced score. So we refer to this. This is the performance. We show it using the use of confusion matrix. Okay. In total, we have 1448 ham in the test data. 1448 plus 0. And we have 28 plus 196 spam in the testing data. So the total is like this. This one, add this one, add this one, add this one. This is the total size of the testing data. But we have more ham than spam. And the model predicted all the ham correctly. No issue. But unfortunately, the model predicted only 196 of them correctly. The other 28, right? They are all spam, but machine predicted them as ham. So if you want a model to be able to predict spam, right? This is bad. Okay? This is bad. So we can refer to this value to understand the performance. Even though the accuracy is very high, 0.983, actually this is not correct. It is very high because it can do this very well. But if you want the model to predict this, but not this one, right? Then the performance actually is not so good. So you can see recall is low. We have one more example here. We pick another algorithm, naive base. We create one object, then we do the same thing, then we test it, then we evaluate the performance. So you can see we have this one. The recall is a lot higher. The accuracy is a lot higher. Why? So you see this round, naive base can do better because it can predict 210 correctly. Even though it missed 14, this is better than this one. This one missed more. Okay? So after you have trained the model, let's say you have done all the things right, then you need to demonstrate the use of it. I have already shared this with you. You can find this in the chat folder answer. So this is just one sample code, to demonstrate the use of the model that we train. So when you do demonstration or presentation in week 12, 13, make sure that you do this as well. Something like this. Okay? Something like this. Let's say I have trained the model. It is named LR, right? I find some sample text. Okay, I find some sample text. So we have example 1, 2, 3. They are taken from this website. They are all spam text. So we can test the model using these 3 spam texts. So the first one is a spam, but the model fails to predict this as a spam. Wrong. When you try the second one, correct. This one is a spam. But you try the third one, right? Fail. So this is the one that we use, LR. You can also try the next one. We train NB, right? NB. So we try NB here. NB. So let's say we change this to NB. Then we start from number 1 again. This round, it can predict this correctly. So naive base can do this better because the previous one failed to predict this as spam. Second one, also okay. Third one, not okay. So something is not right here. Maybe this is too difficult to predict. So during the presentation, make sure that you do something like this. Either you use CLI or you use GUI. You need to demonstrate the use of the model to do something. Now I'm demonstrating the use of this model. I pass this input, it can tell me the output. I pass this input, it can tell me the output. Okay? So don't just show this output. This one is important, but you also need to demonstrate the use of it. Okay? So now you can go through the code, try to understand what happened, and if you encounter any issue, you let me know. Okay? Different algorithms represent different ways for machine to extract the pattern. So why this is better, we don't know. Because we actually do this thing in such a way that we simplify many things. For example, we use car vaporizer. This actually is the oldest technique. And then for this one, we didn't do the cleaning properly. We just do 3 simple steps. There are still noise here and there. So once you get the model trained, tested, you want to know why one is doing better than the other one. So that is the thing that we need to do. Yes? So anyone wants to ask about Simon?
So actually I think doing the supervised machine so we are doing the data prediction and we have a GUI sometimes and then there's a form that allows user to input all the false and then so my problem is maybe I didn't really get the concept, but based on my understanding, the flow will start from find the data set. Right? The data set, after that, we'll do some pre-processing on the data set. And then we have 3 members here. We will use 3 different algorithms to read the data sets and only choose the one with the highest accuracy.
Whether you choose the best one or not, I leave to you. Either you choose the best one, you demonstrate the use of the best one, or you can allow the user to choose the model. Say there's a drop down list. I can select your model, I can select your model, and let's say I select your model, right? Then I can do the prediction. If the result you think is not so correct, right? I can try to use the select another model, do the same thing.
So we can
or you can just sekaligus you provide input, right? It will generate output from the 3 models. Either you select the best one, or you show the result generated by all the models, or you allow the user to select the model. This is not important because the most important thing is that you have done what you should do. So you show one, you show all, you allow the user to select.
So for the data set currently we find we use the tables platform and then there's a lot of different data sets. So we will just only use one data set or
it's up to you. You can use one data set or you can use multiple data sets by right and by right. Let's say you train a model and you notice that model A is doing the best. But then you use other data sets, right? You want to know whether model A is still doing the best. Then if let's say model A can do the best for A, data set A, data set B, data set C, right? Then it is confirmed that model A is the best. So it depends on how you want to do it. You want to try one data set is okay, multiple data sets is okay.
That means that we can each member can one data set.
Correct. So at least one data set, each of you train at least one model. If you want to do more, you can select more than one data set. That means that you have to train more than one model.
So currently my advice is we use 3 data sets. The 3 will be consistent throughout 3 different algorithms. So the 3 data set will be applied on this algorithm, this algorithm, this algorithm.
You see, let's say we use one data set, then we use one algorithm to train one model. If you use 2 different data sets, right? If you use the same algorithm, you will generate at least 2 different models. There are also people who combine multiple data sets and train one model. But when you do this combination, right, it will be very confusing because the combination can be done wrongly. maybe the two data sets they cannot be matched, but if possibly match it, right, then maybe you will face trouble.
For my team, I only have 2 person, right? So we only do for 2 this year.
Only 2 of you in the group. Then each of you do one.
对，老师，因为我们做 chatbot right，so 我们要 free 分个选给user 嘛，就是 user 不要自己问，我们已经有3个选择，还是我们要 user 去问。
If you do it that way, right, then the AI part is very little. You force the user to choose only one thing. Right, if you allow the user to ask to say any question, then the model will try to understand the question, then you will find the match. Maybe there are many different categories, right? You will find one. Then you will choose one response from them.
对，
我是问到什么？就是我们要做的就是我们那个当时里面还会有个数量指标那些，然后我们就被想这样子把出很多那个很48%。
If let's say what you do right is very similar to what you do, then you get to.
我们准备的
If you do it differently with a lot of extra items, then you can see it. Then you get more marks.
website 因为我是没有用过。
可是他问的是3个人的，
中文其实就是一个人可以快慢得到，然后选那个模的时候再出来我们的那个。我的 idea 是这样，我是跟他讲，就是讲，我们这个 user 不是讲，这个 user 就是我们自己。所以发现简单嘛，然后用一个人，然后我们先把我们 So like we're best on as the action, default another default action is of around 180 and then among there there will be like around 200. 出一个人或者是比较简单，就是combine 250 from data set and I found out about 5,000 data. Then after cleaning a bit, still left 最后那个全部是出来的 output.
So I don't know how to do it, but it's like many records of the report.
Because there were a lot of different.
Okay, if let's say you remove duplication data, it's understood. But it is possible that there are duplication, but there are reasons why that maybe with different ratings, and it's ratings or there are reasons, or maybe there are no reasons. You say that there are reasons. Then 我们大概会一个是remove them from 200 to 3K. 这样子我 report 不需要改。因为我们现在当下在there's no
more than
as far as it's not 2 meter but 300, even 1K is considered 2 meter.
So
the more the better.
100K 哦，100毛年呢
？Very little data. You train it. 因为我是每一次 3K 来，你听得到most probably when you train the model using API, right? The model
so it depends on the result.
correct.
So even if the model only trained on 500 data, but then the output is really good, the result is really good.
You can put the thing is really good, really very
这个是你自己的选择。
What I was idea right now is 把那个鱼那个机器剪掉，因为我拍摄影片多少时期的red, green or yellow. Red is the one paramedic under the scenario. The cases that they don't include. 我是觉得全部其实都有directly related to so 有时候 case 全部and the system will predict. I mean, 有一些是会有这些，这也是 optional，因为它 it's not like predict give suggestion, right? Not suggestion. Just do it again. Can. As long as you have the answer, you have the question, then Q&A, okay, but we allow the user to ask question anyway. Okay.
是觉得还不能说，因为 BMI 有点是来heart disease,
It's the model will have yes or no.
usually with would you make it
If you want to do it in that way, right, then it's the simplest way to do it. But if you want to consider the model, I told you already, you know, see what are the useful contributing is identifying the output. Let's say there are inputs, 30 inputs, right? 35% they are not useful. Then you want to consider that because it is small, right? But it is not so that it will consume more results. If you have you cannot just